Lesson 10.3, Arithmetic Sequences and Series. Arithmetic sequences are sequences that have a common difference, which we'll call D, such as 3, 7, 11, 5, 19. Why? Because 7 minus 3 is 4. 11 minus 7 is 4. 15 minus 11 is 4. 19 minus 15 is 4. So if you subtract the term minus its previous term, you always end up with 4 in this case. So the common difference of this arithmetic sequence is 4. Well, so our rule for our nth term would be taking our first term and adding a certain number of these common differences. So, be our first term plus, let's see, to get to the 19, I'd have to add 4 times, but 19 is the fifth space, the fifth term. So it'd be adding the D one less time than the term number. If you distribute and rewrite it, you can end up with AN equals D times N plus C, where C is A1 minus D, or what we just had, AN equals A1 plus N minus 1 times D. Find the rule for the nth term for 3, 7, 11, 15, 19. Alright, so we already came up with D was 7 minus 3, which is 4. Or if you'd like, 11 minus 7 is 4. 15 minus 11 is 4. 19 minus 15 is 4. So D is 4. So we could say it's AN equals A1 plus N minus 1 times D. A1 is 3, and D is 4. So distribute, so that'd be 4n minus 4, and combine like terms will be 4n minus 1. All right, this one's a little more interesting. Find the 8th term of an arithmetic sequence is 25, and the 12th term is 41. Write a rule for the nth term. Well, our rule is AN equals A1 plus N minus 1 times D. However, I don't know A1 and I don't know D. So what I could do is I could plug in two terms. So I could fill in A8, the 8th term is 25. Alright, so that means the N is the 8 and the AN is the 25. So I fill it in, I'll have 25 equals A1 plus 8 minus 1 times D. Or 25 equals A1 plus 7D. And then I could fill in A12 is 41. Again, the N is 12 and the AN is 41. So I'll have 41 equals A1 plus 12 minus 1 times D. Or 41 is A1 plus 11D. So now I have two equations. I can solve this as a system of equations. So if I do that, maybe I'll multiply the one that's 25 by a negative 1 and add these so I have elimination. So if I do that, I end up with 16 equals, well, the A1's add to nothing, equals 4D. So D is 4 again. D is not always 4, it just happens to be in these problems. Then I plug that into one of my equations. So let's plug it into, I don't know, the 41. It's A1 So 11 times d, but d was 4. So subtract the 44, and a1 is negative 3. So now, go back to our original equation, an equals a1 plus n minus 1 times d. But now I know the a1 and the d. Distribute before n minus 4. So our rule will be an equals 4n minus 7. The recursive rule for arithmetic sequences is pretty straightforward. To get the next number in the sequence, you just add d. So we have to have our first term, and then the next term is simply the previous term plus d. Now let's look at arithmetic series. So let's say we want to add together a whole arithmetic sequence. So this is, I'm adding odd numbers, so the d would be 2, and we're starting at 1. So 1. So let's take and let's break this in half right there and write it as 2 separate lines. So I've taken it and it just split around, and I'm adding these. So if I add these, 1 plus 19 is 20. 3 plus 17 is 20. 5 plus 15 is 20. 7 plus 13 is 20. So that makes 5 20s, or 100. Well, that's interesting. So what did we do? Well, that was the first term and the last term. And the number of times that we have that is half of n. So it'll be n over 2 times the first term plus the last term. So let's find the sum of the integers from 1 to 57. So it'd be 1 plus 2 plus 3 plus 4 plus 5 plus up to 57. Well, it looks like the d would be 1, the a1 is 1, and the an is 57. Oh, but wait, how many numbers are there? There happens to be 57 numbers, so the n is also 57. So our sum was n over 2 times a1 plus an. We're adding the first 57 numbers, so n is 57. Our first number is 1, and our last number is 57. And so that gives us 57 over 2 times 58, which is 1,653. All right, find the 50th partial sum. So that means we're going up through n is 50. All right, looking at the sequence, it looks like d is going to be 4, a1 is going to be negative 6. All right, so our sum is n over 2 times a1 plus an. All right, n is 50. a1 is negative 6. Wait, we don't know an. Well, in that case, we will have to figure it out. So an is a1 plus n minus 1 times d. Well, I want a50. a1 was negative 6. N then would be 50. And d is 4. All right, so I'll work that out, and we end up with 190. So an is 190. Run that through the calculator, and our sum is 4,600. All right, for our last example, let's evaluate this summation. But how do we know if this is arithmetic or not? Well, remember the arithmetic formula is an equals a1 plus n minus 1 times d. Or, if we multiply this out, we'd have an equals dn plus c, where c was a1 minus d. But if you look at this, that is linear. So if the formula here is linear, then it is arithmetic. So this is arithmetic. So that means we don't have to actually plug in all the numbers 1 through 100. We could simply use our sum formula. Sn equals n over 2 a1 plus an. All right, remember the top number, the upper limit would be n, so that would be S100. Our first term is when we plug in the 1. The an would be when we plug in the 100. Hundred over 2 is 50. This is 5. And the other part is what? 302. So it'll be 50 times 307, which is 15,350. That's all for today. Have a good day.